Hello, ladies and gentlemen. Welcome to yet another exciting lesson from SAGET Tech. My name is Yosef, and I hope you enjoy this one. And please don't forget to hit the subscribe button below this video for us to be able to keep producing more and more of these wonderful, wonderful, and exciting videos. Good day once more. Today we're treating technology grade 7, and our topic is electrical systems and control. We are focusing today on magnetism. One may ask himself or herself as to why magnetism in electricity. Answer is very simple. We use electricity in order to create magnetism or the magnet, and we also can use a magnet in order to create electricity, more especially when we talk of alternating current. The first thing that we need to think of is the definition or the explanation of a magnet. What is a magnet? And we can simply explain a magnet as a body having the property of attracting iron and producing a magnetic field external to itself. We've heard that in grade 5 NSN Tech, there are metals that are being attracted by a magnet, and there are those that are not attracted by a magnet. And these ones that are attracted by a magnet that a special characteristic of having an iron in their composition. And we also say for a magnet to be able to attract any piece of iron or another magnet, it's because of external force around the magnet, which is called the magnetic field. Magnets are, of course, divided into two types. The first type is a permanent magnet, and the second type is a temporary magnet. And we can explain a permanent magnet as a magnet that retains its magnetism for a very long time or eternally. These are usually the natural magnets that are found in nature. That rock that was found somewhere in Magnesia underneath the ocean and having the characteristics to attract some of the magnetic materials which contain iron, like I have already explained. Now we've got what you call temporary magnets, which retain their magnetism only while current is flowing through the circuit. And these kind of magnets are termed to be called electromagnet because they only retain their magnetism when current is flowing through the circuit. Now, magnets are made in different shapes, being it electromagnet, which are temporary, or the permanent magnets. We've got the bar magnet. It looks like a bar. There it is. We also have the horseshoe magnet. It looks exactly like a horseshoe. The other shapes are round, which are usually found in speakers, radio speakers. We also have the cylindrical shape magnet that looks like that. Now, let's see how these magnets of ours are constructed. We are saying magnets have got two poles, the south pole as well as the north poles. These poles are situated on either point or either side of a magnet. As you can see, we've got to our left here the south pole, and our right the north pole. And we are saying same poles, which is north and north. If you've got two different magnets, are said to be like poles, and south as well are said to be like poles. And opposite poles, meaning south and north, are said to be unlike poles. So you've got two magnets next to each other. If you bring north to the south, you must know that you are bringing unlike poles together. Now coming to magnetic and non-magnetic materials. Again, this was done in grade 5 NSN Tech, and we are saying the magnet has a special characteristics of attracting some metals. And I want to emphasize that some metals because some cannot be attracted. But we need to understand that the metals that are attracted by a magnet are therefore called the magnetic metals or magnetic materials. The examples of such are iron, steel, and nickel. these ones can be attracted by a magnet. But we've got to think of the reason why they are attracted by metals. If you look into the construction of these type of metals, you would realize that all of them have got one characteristic of having iron as part of their structure. They do have iron in them. Therefore, we can conclude by saying magnets do attract metals or materials which contain iron within their structures. There are, of course, other metals that do not or cannot be attracted by a magnet, and those are called the non-magnetic metals. And examples to such are copper, aluminium, lead, and brass. The reason is simple. They do not contain iron as part of their structure. Therefore, they cannot be attracted by a magnet. And it is also important to note that all non-metals are not magnetic as well. Non-metals like wood, like plastic, like rubber, as long as it's a non-metal, they are as well a non-magnetic material. Now we come into magnetic lines of force, or that force around a magnet. You'd realize that if you put a magnet next to each other, if it's like poles, they repel, if unlike, they would attract. But they need to be at a certain proximity or at a certain distance from each other for repulsion and attraction to start happening. Even when you take a magnetic material or a magnetic metal like iron itself and put it closer to a magnet, there is a region in space where it will be attracted, but as it moves further from the magnet, the magnet loses that ability to attract it. Its strength of attraction become weaker and weaker as an object moves away from it. And that region in space around the magnet, wherein magnetism is effective, it's called the magnetic field. And as I've already indicated, the further you go away from the magnet, the weaker it's your magnetic field. Now, the magnetic fields are displayed or shown by the field lines. As you can see in this picture, here are the lines of force, and you'd realize they are so dense at the poles, meaning that at those poles they become very, very strong. The attraction of the magnet is very strong in the poles, but as you move further away from the poles, the ability of the magnet to attract and repel become weaker. And the last thing that we're going to be looking at is the universal law of magnets, which states that like poles repel each other. As you can see, north and north will repel, south and south will repel. Repelling means that they never touch each other. When you try to bring them together, they chase each other away from one another. Being it south and south or north and north, they will never be attracted. They will never touch each other. And we've got unlike poles attracting each other. When you put North Pole closer to the South Pole, within reach of each other's magnetic field, they will attract each other, and it will be a bit difficult for you to try to separate them, meaning that North and South, which are unlike, do attract each other. That was the last part of our lesson today. Until we meet again in the other lessons, please keep coming back to our channel, SAGET Tech, for more of these type of lessons. And please don't forget to hit the subscribe button and leave your comment for any question or any assistance that you'd like to have for us as far as our lesson or today's lesson is concerned. I thank you.